Hi, this is Grover with Blue Collar Codes, the Quick and Dirty, episode 21. I'm going to go over data structures, very high level, and discuss a bit more of how classes are created just in the code itself, and then how to create a node-based class, which is the main building block of a lot of data structures, such as trees and linked lists, and then how slots plays a part in that and how it changes the class. If you wish to follow along, you can find episode 21.py in the GitHub repository, which is linked in the video summary. So to start off, I'd just like to show you that you can type dir in the interactive prompt and then just do object. All classes inherit from object. And all of these double underscore or dunder methods are kind of unique to the built-in. You can alter the way that your class is going to operate if you alter a lot of these dunder methods. And a lot of them would be like, so what do you want to have happen if somebody uses a greater than symbol to see if it is greater than one thing or the other? Or if you want to do less than or equal to, what do you want to do if it's going to be printed? Or if somebody prints it in the command line and to standard out, do you want it to be looking different using Repo? And what have you. So these are the base building blocks or what comes with your class if you just leave it empty and use pass. Now, if we create a class ourselves and do the length of the ears, now if I do b equals bunny, now if I do dir on the bunny instance that I just made, what you'll find is it changes a bit. It has more dunder methods, as well as now it has a dict object. And this is the storage for all the attributes and methods that you outline. It also becomes the storage for, say, references to superclasses. So here, just to outline, I mean, you're only going to get one output here because all we have is length, but you can do b dot underscores dict, and what you get is just that one attribute. Now, if you have a class that has a lot more attributes, then these are going to be a part of it. And what this is it's a link and a reference to an actual dictionary of all of these things. So that's important to note just because of the memory overhead that is required to house a separate reference to an actual dictionary object. And that is how normal classes are storing, say, methods and attributes. Now, if you use slots, what you're having is that on the instance itself, it is just going to house the variables that you are using slots with. So for in this example over here, in a node class, I'm using slots to tell Python that I want these data points to be stored in, say, just a memory efficient manner. So they're going to be stored on the instances themselves, and then any other calls to acquire or add different data points is going to come up with an error. And the purpose of slots is mainly for creating such things as a node, so that you want to have a linked list that has, say, thousands upon thousands of these nodes with these data points, and you want it to be memory efficient and not house all of the, let's say, boilerplate of the object class itself. So if you're inheriting directly from object and you don't use slots, there's a lot of overhead that can be reduced using slots. So that was kind of a brief overview of, how classes are structured, behind the scenes a bit, without trying to dive into what each one of these is and how it is used. But just know that it exists, and if you're ever curious, you can start when you create classes and you do inheritance, you can look in the dictionary and you look in the class and see how things change based on what you're changing. So specifically for data structures, it is necessary to have a class that doesn't have as much memory overhead, especially because it's just going to be used to house data, house a reference to either next, to the next node, or a previous node if it's a doubly linked list, to its children if it is going to be used in a tree structure, or its parents, and so on and so forth. So let's talk just briefly about what a linked list would look like. A doubly linked list. So a doubly linked list means that each node is going to be linked to the next node and the previous node, except for the head and the tail of the linked list. So at each one of these nodes, you're going to store a data point, and then there are going to be methods attached here that'll allow you to go to the next item. And so some of the stuff that is good or works well with linked lists and storing this data in that kind of a structure would be, say, a queue or a stack, or working with the kernel or operating system elements. But this video is just basically going to give you a very high-level overview of slots and then the node base class. This is Grover with Blue Collar Codes, Quick and Dirty. Thanks for joining.